revise the rectus abdominis muscle. As you know, the anterior abdominal wall is formed by 3 flat muscles and 2 vertical muscles. Now this rectus abdominis is one of the vertical muscle which takes origin in 2 heads, medial head and lateral head. Now the medial head of rectus sheath arises from the anterior surface of pubic symphysis and the lateral head, it arises from the pubic crest and pubic tubercle. Then the muscle, it inserts in this muscle inserts in 4 fleshy slabs. One slab is inserted on the xiphoid process, the other 3 on the 5th, 6th and 7th costal cartilages. That means this muscle, it does not exist or extend above this costal margin. So this is the xiphoid process and this is the pubic symphysis. And here this rectus abdominis, it arises from medial head and lateral head and is inserted on the xiphoid process and 5th, 6th, 7th costal cartilages. This is the umbilicus. This muscle is present on either side of this linea alba. Now this linea alba is a tendinous raphe which is formed by the interlacement of the aponeurosis of all the 3 flat muscles of the abdominal wall. So this is the rectus abdominis. Now this rectus abdominis, it has 3 tendinous intersections which are present, one at the level of the xiphoid process, second is at the level of this umbilicus, and third tendinous intersection is present the midway between these 2. Now this is the one-sided rectus abdominis. Now what is a rectus sheath? Now this rectus sheath is an aponeurotic envelope which of this rectus abdominis and of the pyramidalis muscle. Now this rectus sheath, how it is formed, the formation of it, and this sheath discovers the rectus abdominis and it has anterior wall, it has posterior wall, it has medial margin and lateral margin. Now as you know that this lateral margin or lateral border of this rectus abdominis is called as linea semilunaris, which extends from about the stick of the 9th costal cartilage below the pubic tubercle. So it is a curved line. Now how this rectus sheath is formed? The principle of the formation of the rectus sheath is the splitting of the aponeurosis of the internal oblique muscle. Internal oblique aponeurosis. Now this internal oblique aponeurosis, it splits into 2 laminae, anterior lamina and posterior lamina. So this is the principle of this formation of this rectus sheath. Now this rectus sheath, anterior wall, it is firmly adherent to these tendinous intersections, and the posterior wall, it is free from the posterior surface of this muscle. deficient above the costal margin and below the arcuate line. That means the midway between umbilicus and pubic symphysis, the posterior margin is deficient over here by forming an curved line which is concave downwards, and this curved line is called as arcuate line. It is concave downwards. So, how the anterior wall is formed? Now, this anterior wall, the thickness of it varies at 3 levels. That means above the costal margin, in between the costal margin, and at this level of arcuate line, that means the midway between umbilicus and pubic symphysis, and below the arcuate line. So first we'll see the formation of this anterior wall above the costal margin. Now above the costal margin, this is a thin line and is formed by only the aponeurosis of this external oblique muscle of the abdomen. This is the xiphoid process. This is rectus abdominis, and this is the external oblique and its aponeurosis. So, above the costal margin, the anterior wall is formed by this only the thin layer of this aponeurosis of this external oblique muscle. Now, this anterior wall at the level of means between costal margin and up to this arcuate line, it is thick and is formed by the anterior lamina of this internal oblique muscle and aponeurosis of the external oblique muscle. So it is thick as compared to this upper part of this anterior wall. So here, this is the internal oblique muscle which splits into 2 laminae. This is the anterior lamina along with the aponeurosis of this external oblique, and this is the linea alba. So here the splitting of this aponeurosis of the internal oblique. So anterior lamina of the internal oblique along with the aponeurosis of this external oblique muscle, it forms the anterior wall between this costal margin and the arcuate line. So it is comparatively thick. Now below the arcuate line, so at this level, here the splitting of this internal oblique muscle, it does not extend beyond this arcuate line, and above the costal margin it doesn't extend. So below the arcuate line, here aponeurosis of all the 3 flat muscles of the abdomen, they form the anterior wall. So this part is thickest. Here the aponeurosis of internal oblique and transversus abdominis, they fuse with each other, but the aponeurosis of this external oblique, it remains separate, and below this level the rectus abdominis, it rests on the fascia transversalis. So, the thickness of anterior wall, it varies. See here, below the arcuate line, the splitting of this internal oblique does not extend. That is why below the arcuate line, this anterior lamina or anterior wall of this sheath is formed by this aponeurosis of all the three flat muscles. So this is the thickest part, and below this line, this rectus abdominis, it rests on the fascia transversalis, the thick part of the fascia transversalis of it, which is called as iliopubic tract. So this is the fascia transversalis. Now we see the formation of this posterior wall. Now, as you know, this posterior wall, it remains free from the posterior surface of this muscle, and it is deficient above the costal margin and is also deficient below this arcuate line. So, this posterior wall is present only between this costal margin and up to this arcuate line. Now, how this posterior wall is formed? Is formed by the posterior lamina of internal oblique muscle and the aponeurosis of the transversus abdominis. So, this posterior wall is formed by this posterior lamina of internal oblique aponeurosis along with the aponeurosis of the transversus abdominis, and is deficient below the arcuate line and above the costal margin. Above the costal margin, this rectus abdominis is rests on the costal cartilages of 5, 6 and 7th costal cartilages. Now this rectus sheath, as you know, this is an envelope, aponeurotic envelope. So what are the contents of this rectus sheath? Now this sheath, it consists, the most important content is the rectus abdominis and the pylorus muscle. When it is present, the vessels are superior epigastric artery and inferior epigastric artery. See, this is the superior epigastric artery. And this is the inferior epigastric artery. Now, both these arteries, they anastomose at the level of the umbilicus. The veins which are present in this sheath are superior epigastric vein commitants. They accompany of its artery and they join the internal thoracic vein. Now the inferior epigastric vein commitants, they accompany its artery and they join the external iliac vein. Now, which are the nerves present in this sheath? That is lower 6 thoracic nerves. That means anterior rami of lower 5 thoracic nerves and subcostal nerves. So these are the contents of the rectus sheath. Now this is the formation and concept of this rectus sheath. Now what is the newer concept of this rectus sheath? According to this newer concept, all the 3 flat muscles they split. That means aponeurosis of all the 3 flat muscles, they split at their medial borders into two laminae, that is anterior and posterior lamina of each. And this anterior wall, now according to this concept, how this anterior wall is formed? Now this wall is formed by both the laminae of external oblique aponeurosis along with the anterior lamina of internal oblique muscle. Now how this posterior wall is formed? According to this concept, the posterior wall is formed by the posterior lamina of internal oblique along with both the laminae of transversus abdominis muscle. Now according to this concept, both the laminae and all the fibers, they decussate, and they decussate with the opposite fibers, and at this midline they form this linea alba. Also, decussation of fibers is also present in between both the laminae, also to the opposite side. Now, the direction of muscle fibers is obliquely upwards in the anterior wall, upwards, and in the posterior wall, the direction of fibers is obliquely downwards. That means these fibers, they run at right angles to each other. So the direction of fibers of anterior wall and posterior wall at the right angles to each other. So this is the new concept, that is all the three aponeuroses, they split into two laminae. Now what are the functions of this rectus sheath? Why this muscle is enveloped only? So this rectus sheath, it prevents the post-springing of the muscle during its contraction, and hence it increases its efficiency. So this is about this rectus sheath. Now the next topic is the inguinal canal. Now what is this inguinal canal? What is the definition of it? Now the inguinal canal, it is an oblique intermuscular passage which is present above on the medial half of this, above the medial half of this inguinal ligament. Now what is the length of this inguinal canal? The length is 4 centimeters or 1.5 inches. Now extent of this canal, it extends from deep inguinal ring to the superficial inguinal ring. Now I have told you this is an oblique intermuscular passage. So the direction of it is directed downwards, forwards, and medially. Now what are these rings? Superficial inguinal ring and deep inguinal ring. Now in the morning, as I told you, this deep inguinal ring is an oval ring or oval opening which is formed in the fascia transversalis 1.2 centimeters above the mid-inguinal point. And this superficial inguinal ring, it is triangular in shape. Now this base of this triangle is formed by pubic crest. And both these opening in the aponeurosis of oblique muscle. Now it is this opening, it is 2.5 centimeters long and 1.2 centimeters broad at the base of the triangle. Now these two medial and lateral margins of this triangle, they are termed as crura. Now at the apex and beyond the apex, these two crurae, that is these crurae, they are connected with each other by the intercrural fibers. Now this inguinal canal, it has anterior wall, it has posterior wall, it has roof, it has floor. Now the floor of this inguinal canal is formed by the grooved part of the inguinal ligament. Now this roof of the canal is formed by the arched fibers of internal oblique and transversus abdominis muscle. Again, the internal oblique muscle has triple action related to this inguinal canal, as it forms the anterior wall, also it forms the roof, and also it forms the posterior wall of the canal. Now, as it is a canal, then which structures passes through it? Now, in males, spermatic cord in case of males, and round ligament of uterus in case of females. So, these structures passes through this inguinal canal along with ilioinguinal nerve. The spermatic cord in male and round ligament of uterus in case of females, these two structures, they enter through deep inguinal ring and they pass out through the superficial inguinal ring. And this ilioinguinal nerve, it enters the canal in the gap, through the gap between internal oblique and transversus abdominis muscles, and it comes out through the superficial inguinal ring. So this is about this. These are the contents of this inguinal canal. Now this inguinal canal is a cause of weakness in the lower part of the anterior abdominal wall, and this weakness is compensated by these mechanisms. So this weakness is compensated by these following mechanisms. So whenever there is a rise in intra-abdominal pressure, for example during coughing, sneezing, lifting heavy weight, defecation, micturition, etc. So there are the chances of herniation of this abdominal viscera. Now this herniation is prevented by all these mechanisms. First is flap valve mechanism, which is also called as guarding mechanism. Now, as this passage is oblique, see, of this side, this is an oblique passage. So, both these rings, superficial and deep inguinal rings, they does not lie opposite to each other. So, whenever there is a rise in intra-abdominal pressure, these openings, they are closed and this passage is obliterated. By closure of this openings, and this passage is obliterated, and this mechanism is called as flap valve mechanism or guarding mechanism. The cause is obliquity of the passage. Now the second mechanism is superficial inguinal ring. Suppose this side, this is the triangular superficial, and this is oval. This is the umbilicus. So this superficial inguinal ring is guarded behind by the conjoint tendon, and this deep inguinal ring, it is guarded in front by the internal oblique muscle. So this is the second mechanism. Both these rings, they are guarded. Superficial is guarded by conjoint tendon, and this deep ring is guarded in front by the internal oblique muscle. Now what is wall valve mechanism? So whenever there is a contraction of cremaster muscle, it plugs this superficial inguinal ring by the spermatic cord. So whenever there is a contraction of this cremaster muscle, it plugs this superficial ring by the spermatic cord. Thus, it obliterates this canal, and this mechanism, it is called as wall valve mechanism. What is shutter mechanism? As I told you, this internal oblique muscle, it has triple relation with this inguinal canal, as it forms roof of it, as it forms the anterior, as it also it forms the posterior wall of the canal. So whenever there is a contraction of this internal oblique muscle, it brings the roof towards the floor. So it approximates roof with the floor like a shutter. So this mechanism is termed as shutter mechanism. Now what is slit valve mechanism? As you know that this superficial inguinal ring is triangular in shape. Base of it formed by cubic crest, and these medial and lateral margins, they are called as crurate. And this superficial inguinal ring is formed in the aponeurosis of external oblique muscle. Now, whenever there is contraction of external oblique muscle, it approximates both these crurate, and thus this superficial ring is closed by obliterating the canal, and that is why this mechanism, it is called as slit valve mechanism. Again, hormones also play a role in the tone of this inguinal musculature. So hormonal factor is also there, which also obliterates the canal. So whenever there is a rise in intra-abdominal pressure, all these above mechanisms, they come into play, and they closes both the rings and thus obliterates the inguinal canal, and thus prevents the herniation of abdominal viscera. So this is all about the inguinal canal. Now, in case of males, the inguinal canal is larger as compared to the females. So these factors, they will help you in understanding the inguinal hernia. these were the topics of the dissection. In short, I told you theoretically. The lectures of it will be taken in details. So that is all.